in our third video on Le Chatelier's principle, we're going to look at the effect of change in temperature. So when we change temperature, what we need to think about is whether in that original reaction heat is being released, it's an exothermic reaction, or heat is being taken in, it's an endothermic reaction. So if heat is being released, as we go from left to right, that reaction gets hotter. So it's not going to want us to apply any more heat, and if we do, it's going to try to go back in the opposite direction in a way that takes in that heat and uses it to cool the reaction down. So we have to know what we mean by these signs. So having a look at this, we can see here that we've got a negative sign. So we need to know that when we've got a negative sign there, that this reaction is exothermic going forwards. And what we mean by exothermic is that heat is released. Okay, so heat energy is released from the chemicals. So it's exo going forwards, which means it's endo going backwards. It takes the heat in backwards. The enthalpy change for the reverse reaction would be plus 92.4. So in this case, the forward reaction is exothermic. So an increase in temperature will cause the equilibrium to shift backwards away from that, so to shift to the left to absorb any heat that we're putting onto it. It doesn't want us to put more heat on, so it's going to take that heat in, and the taking heat in direction is backwards, so it's going to go backwards, and the position of equilibrium will move to the left. So wherever we were before, we're going to go left. So we've gone left to oppose the change and absorb the heat. In order to increase the yield then, we would want it to go right, and in order to make it to go right, we'd need to use lower temperatures so that as we cooled it down, it tried to release more heat to oppose us. What about a reaction where our forward reaction this time has a positive sign and therefore it's endothermic? What that means, when something is endo, is that heat is absorbed going forward, heat in. Alright, so we're going forward, it's getting cooler as we go forward. So if we were to heat this up, then it's going to shift to the right to oppose the change and absorb the heat, because going right does absorb heat this time. So these reactions, endothermic reactions, will increase yield when we use a high temperature. Remember again, this is about position of equilibrium and not rate. Increasing always increases rate because more particles have energy greater than or equal to the activation energy, more collisions are successful. Remember as well that you could be asked what would happen if you would lower the temperature, so you have to think, well, if I cool it down, it's going to shift to release heat. So talk about moving in the exothermic direction. While we're on this video, we're also going to have a look at the effect of a catalyst on equilibrium. And the catalyst has no effect on equilibrium position or yield, and that's because it will both increase rate of forwards and reverse, and it does so by the same amount, and therefore you don't see a difference in that position of equilibrium or in the yield. So there we go. Increases rate forward and reverse by the same amount. It always increases the rate, so for when we're talking about rate questions, it always increases the rate because it lowers the activation energy. More particles have energy greater than or equal to the activation energy. So it always increases the rate, but has no effect on the position because it's increasing the rate of the forward and the reverse by the same amount. And in an exam, it's really important that you pick out both those features. It increases the rate of the forward and the reverse reactions, and this bit by the same amount. They're looking for both those key terms.